So, rational expressions and simplification, we got two polynomials. And the main thing you guys got to do before we go on is to take your greatest common factor out of both the numerator and the denominator. So what's your greatest common factor here? It's going to be a 3, and what else can you take out? M. Okay, so what I want you to do is take a moment, find what is left inside that bracket. What can you take out of the bottom? A 6. Okay, so find that. I'm going to pause this. Find that for a moment, okay? All right, so what you should have gotten was this. So we factored out a 3m and a 6, but we still got a polynomial there. And what we need to do next is do the box method to find the factors of both the numerator and the denominator, okay? So what I'm going to do right now is erase this, first of all, so I have some room. I'm going to do the box method with this top polynomial here. So if I have my box, this term right here, the m squared, is going to go on the top left. Bottom right is going to be negative 5. I'm going to multiply this diagonal together. So m squared times negative 5, that's going to be a negative 5m squared. And I need to find my factors of negative 5m squared that will add up to be negative 4m. It's going to be 1m and negative 5m. Okay? So I can put those anywhere in here, these two leftover boxes. Okay. So, top row, what can I factor out? An m. Bottom row, negative 5. Good. Left column, an m. Right column, a 1. So my factors are going to be m minus 5 and m plus 1. Okay? We need to do the same thing for this polynomial. Okay, so I have an m squared here and a 15 here. If I multiply my diagonal together, I got 15m squared. So what are my factors? Yep, we need it to add up to be negative 8. So we can have a negative 3m and negative 5m, right? So I'll put that in here. What can I factor out of the top row? An m. How about the second row? It's going to be 5. Now remember, with this type of thing, because we have this negative up here, that means this one's automatically going to be negative. First a negative, then a positive makes the second term on each of these binomials negative. Okay? This one, I could take out an m, and on this one I could take out a negative 3. So, I have m minus 5 and m minus 3. So if I replace these two polynomials with their factors, what I will end up having is this. I can obviously cross out the m minus 5. They have that in common. And I can reduce this fraction of 3 over 6. 3 divided by 3 is like a 1, right? And 6 divided by 3 is a 2. So my final answer on this is going to end up being 2 times m minus 3 for the denominator, and m times the quantity m plus 1 on the numerator. My question to you is, what can m not be? And remember to base it on this denominator right here. It can't be a 5 and it can't be a 3. Good. Because if I set both of those equal to 0, I'll get 5 for m. 5 minus 5 is a 0. And 3 minus 3 is a 0. And you cannot have a 0 in the denominator. Okay? 1, 2. Okay, so on this first one here, the first step. What did I tell you last time? What was the first step you had to do for this? Greatest common factor. So what would your greatest common factor be on the top? You could take out a 2. What can you take out of the bottom? Not a 5, because 5 doesn't go into 33. Just an x. So do that right now. See what you get. And then we'll compare. All right, so gave you a moment. Let's look and see if you guys got the same thing I did. Over here, I have 2 times the quantity x squared plus 7x plus 10. And x times the quantity 5x squared plus 33 plus 40. Okay. Now, we need to break this down further. That means I need to do a box method for both the bottom, the denominator, and the top. I didn't write this out over here, but I will. So I want you to take a moment to try to find your factors of both of these. I got them both started for you. So do that. All right, so on this first one, the factors of 10, 5, and 2, because those add up to be 7x, right? So 5x and 2x. And I could put those anywhere in my box here. Well, in the 2 blank spots. Okay, so if I factored out the top row, I would get an x here. Bottom row, I would get a 2. If I do my left side, I would have an x. My right side, I would get a 5, if I put it right there. So my 2 factors are x plus 2 and x plus 5. Right? That was the easy one. This one's not as easy. So 200, I already know that 5x and 40x go into that, but if I add those together, I get 45x. And we need 33. So I know I'm close. 45 is not that far from 33. So what is the next factor up from 5 that goes into 200? 8. So 8x and 25. 8 plus 25 is 33. So that works out for us. So I'm going to put that in. What can I factor out of the top row? An x. How about bottom row? A 5. Yep. Okay, left column, I could factor out a 5x. Right column, I could factor out 8. Okay, so my 2 factors here are x plus 5 and 5x plus 8. Now, if I take this and put it back into my rational expression here, replace my polynomials with their binomials, this is what I get. I can cancel out my x plus 5. They both have that. Is there anything else I can cancel? No, there isn't. Okay, so my answer for this, as simplified as I can go, is 2 times the quantity x plus 2 and x times the quantity 5x plus 8. But I still need to find out what my values of x are that are not possible. And remember, when I'm doing that, I am looking at the denominator right before I canceled everything out. So what are my 3 values of x that x can't be? It can't be a minus 5. That's based on this one right here. Well, no, it can be a minus 8. It can't be what? How about this one? A 0. Now, the last one, we need to set that equal to 0. 5x plus 8. When is that equal to 0? That's what we're trying to find out. So I'm going to subtract 8 from both sides. So I have 5x equals negative 8 divided by 5 So x equaling to negative 8 over 5, that is a time when we can't have. So those are the three values. Negative 5, 0, and negative 8 over 5 that we cannot have. Any questions on that?